All right, in this video, we're going to take a look at a problem from a samples test. This is problem 6, and we're going to be doing a t-test on the difference of the means. This is going to be an example of a paired mean, so a paired test. So this means that basically in this problem, we were given a pre-test and a post-test, and we wanted to check the mean difference. So in the previous problem, we had the control group and the treatment group. They were different people. So we had to do a t-test on the difference of means, but with assuming equal variance. Well, this one, we're going to treat it like there's only actually 6 people, but the same 6 people over before and after. That's why n equals 6 and degrees of freedom is equal 5 for this one. And basically, we're going to go ahead and calculate the differences, and we're going to treat that as a regular t-test. So notice here the null hypothesis is that the mean difference equals 0. So it's kind of like mu equals 0, but mu is of the differences. And the alternate hypothesis is that the mu of the differences is not going to equal 0. So because it's not equal 0, that tells us it's a two-tailed test. All right, so let's go ahead and calculate our differences. So here we're just going to take before minus after. Okay. I'll go ahead and copy that formula down. And then we can calculate the mean, which is equal to the average. And I'll go ahead and select my differences. So the average difference mean is negative 2.5. And then we're going to want to go ahead and square the difference between the difference of the mean. Let me go ahead and put the parentheses in. Between the difference of the mean and the mean. Now remember, we have to make this an absolute cell reference, so I'll hit F4 as a shortcut. So when I drag my formula down, it uses that same mean in everyone. Let me go ahead and take that difference and square it. And I'll go ahead and drag my formula down. Okay. Good. Now this SS, the sum squares, so it's going to be the sum of this column right here. So I'll go ahead and use the sum formula and sum all those square differences up. So remember the variance. We're going to take the sum of squares and divide it by we're going to divide that by n minus 1, which is 5. All right. Now, to get the standard deviation, all we have to do is take the square root of the variance. Okay, so we get 7.134. And we'll also make note of that number because we'll see it again when I show you how to do this on the calculator. We'll check that all these numbers match up. So we have to compute our t-statistic, which is just the, well, since our null hypothesis is mu equals 0, so we take this negative 2.5 and subtract 0, so that's just negative 2.5. And then we have to divide by the standard error, which is going to be S standard deviation divided by square root of n, which is 6. Let's type it in. Okay. And that gives us a test statistic of negative 0.83. All right. So the next thing it wants us to do is calculate this critical value for t. So let's remind us that this is at a significance level, or it's 95% confidence. Oops. Which means the level alpha, or level of significance, is 1 minus level of confidence, which equals 1 minus 95%, which equals 5%. So as far as alpha goes, this is 0.05 level of significance. Okay. So you can look this up on the t-table, and we will take a look at that. But we can also use the t distribution. So if I look up equals t dot distribution dot 2t, those are two tails. It wants my no, actually, I'm sorry. We know the area to the left of the t-statistic, so we're going to use the inverse two-tail. And the probability is going to be, for a two-tail, well, the level significance is 0.05, and we're doing it with a two-tail test. It has degrees of freedom of 5. Oops. Okay. Let's try this again. T dot inverse norm 2t, two-tail. And the probability again is 0.05 for the two tails, and the degrees of freedom is 5. Okay, so that gives us a test 2.57. Okay, and I also want to go ahead and calculate the p-value using Excel. This is going to equal, so two tails. There's going to be 2 times the area in the one tail, which is going to equal the t distribution. So t dot distribution, and we'll use so we're going to use the test statistic. So negative 0.8. Oh, we'll just click on this, I guess. We'll use this number. Degrees of freedom again is 5. And then cumulative, we're just going to put true. Okay, that's going to be everything less than that statistic. We get 0.4406. All right, now I want to show you how to get these values on the table as well. So we wanted to find a critical value of two-tail with 5%. So if you just pull up a table, let's see, here's one here. This is upper tail probability, so it's symmetric. So if you were looking for a lower tail, you just take the negative of it, right? So we want the probability in the upper tail to be 0.025 with 5 degrees of freedom. Okay, so it's 2.571 or negative 2.571 because it's symmetric, so it's both of them. So notice that, let's see, notice 2.571 is what we would round here if we looked in the table, okay? As far as p-value, we can go look at that table again. Well, not that table, but you could look at the table and find out the area to the left of this t-statistic, negative 0.83, then you can just double that. So let's take a look at what this looks like. Let's get a new page here. All right, let me put this up over here. Okay, so we have this t-distribution. Okay, and we had some critical values of, let's say, negative 2.57 and 2.57. Okay, so again, these are your t critical. All right, so this here to the in the tails is our rejection regions. Okay, so let's type this. This is going to be reject. It's so big. I say this is going to reject HO. Okay. And this, oh, there we go. Oh. And this region over here is going to be reject HO. And this one over here is going to be fail to reject the null hypothesis. Okay. So we calculated a test statistic. Let's say it was t, and that was negative 0.837. Notice this clearly falls in the fail to reject the null hypothesis. Okay, so that's one way to do a test. The other way you can do a test is with the p-value, and I'll just show you that real quick. I'll just erase these. So here, all right, so here we calculated the test statistics. Let's just say this was, and this is not the scale, but you get the idea, that this was negative 0.837, and this was 0.837. Okay. And let's get rid of these two. Okay. So what we have here is from our test statistic, we can take a look at the tails. And the combined total of these tails, the probability in these tails is going to be my p-value. So if I were to add these both together, I would get my p-value. And all we have to do is compare our p-value, which we calculated to be 0.44, let's say, and compare it with our level of significance of 0.05. Okay, that was alpha. All right. And we say is 0.44 less than or equal to 0.05. And this is clearly not equal. So it is greater than, which means that we would fail to reject the null hypothesis. Okay. So let's take a look again of how to use this data tool for data analysis in Excel. We can go ahead and go to data analysis. So again, this is a t-test for paired two-sample means, okay? And then for the first variable, we're going to select the before group. And for the second variable, we're going to select the after group, okay? Hypothesized mean difference is 0, okay, so we can see that up here. And then the level of significance alpha is 0.05. And let's just hit OK. Let's go ahead and paste this into our other worksheet and compare our answers. So let's go ahead and post it over here. All right. So notice that difference in means is 5, so that matches up. And our t-statistic is negative 0.837, so that also matches up. The t-critical in the one tail, or in the two tail, is 2.57, so that matches up here. And the probability in the two tails is 0.4406, that's the p-value, and that matches up with our p-value here. Okay, so that's good that matched up. Again, this is t-test with paired two-sample for means. We treat it as almost like a single t-test, just based on the differences. Then I want to show you how to do this on the calculator too. So on this calculator, you can have these lists. So if you hit stat, let's turn it on first. So if you hit stat and edit, you can make your list. Now I've already kind of put in list 3 and list 4 the before and afters, okay? But you go with clear list and do, in fact, I'll show you how to clear. Let's go ahead and clear list 5. So I'll go ahead and hit clear. Okay, and you can just add your numbers in. Okay, and then another thing you can do is you can access the list. So let's do second stat. Okay, and here I get a list of names. So list 3 was my before. And if I subtract that from my list 4. Okay, I actually get my differences there, and I can actually store this if I hit my store button down here as list. Let's call it 5. Okay, so list 5 is my differences. You can see that those match up with the differences here, and that's what we're actually going to be performing the z-test on. All right, so back to the calculator. So to do the t-test, we can go over here to second vars. Oops, I'm sorry, vars. No, second vars. And I'm sorry, second stat. Oh, just stat. Okay, just stat. And then go over to calculations and go down to t-test. Again, we're treating this as a single t-test because we're just doing another difference. So we use the data, u equals 0. We're using list 5. That's the difference of list 3 and list 4. It's a two-tailed test, and we go down to calculate. Okay. All right, here. So we get our t-test statistic, negative 8.37. That matches up with what we had down here. Gets our p-value, 0.4406. That matches up with what we calculated here. You see here's our mean of our differences. Our standard deviation is 7.314. That matches up with what we calculated. So there you go. There's the information there for you. All right, the last thing I want to show you is how to get the probabilities and the t-values. So here, the critical value t, or let's do the p-value. The p-value t was the probability was less than the test statistic times 2. So if we go to second vars, we go down to TCDF, okay, and then our lower bound, again, we could just use something very small, or at least 4 standard deviations away. So -4 would work. We'll use -10. I usually like that. And then for the upper bound, we'll put in our test statistics. So let's do -0.837. That'll be sufficient. For degrees of freedom here, let's put 5. And we'll go down here and paste it in. Okay, so you get 0.2202, and if I multiply that by 2, because that's the one tail, multiply that by 2, I get my 0.4405, so that's my p-value. If I was looking for the critical value, I could do second vars, go down to cumulative, and here, I'm sorry, if I want to do the critical value, I need to take a look at the area, so that's the inverse t. So that'd be second vars inverse t. So that's like, I give it the area and it tells me what the t value is. So I know the area to the left of the tail is 0.025, right? Because it's a two-tailed test. Let's go back and look at this picture real quick. I've already erased it. So remember that it was a two-tailed test, and we knew there was 95% level of confidence, which meant there was a combined total of 0.05 left over. And if I were to look at what's in each tail, I can divide that by 2 and get 0.025. So that means this must have 0.025 to the left, whatever t critical value this is, right? So if I want to find this t critical value here, this is going to equal that inverse t of 0.025. And I guess we need degrees of freedom 5. Okay. So let's go back to the calculator. The area is going to be 0.025. We use degrees of freedom of 5, and we'll go down to paste, and we get -2.57, which is exactly what we got when we looked it up on the table and when we did the calculations using Excel. And when we use the data analysis. So everything matches up. The world is good, and I hope you found this helpful.